Hi, I'm Sherry. In this module, we will introduce the new feature supporting ADAM 6000 CE and D version, which is the MQTT protocol. Here are the objectives you are expected to understand in this training module. We will divide this training module by the following three parts. First, in MQTT basic part, you will understand all basic knowledge or technical terms about MQTT. Second, in MQTT packet introduction, you will understand more details about the MQTT packet information and what data are stored in ADAM's MQTT packet. In the last part, we will introduce how to start MQTT with ADAM steps by steps. Let's move to the first part. What is MQTT? In IoT era, we need standard protocol for small devices. One of the most promising and popular protocol for small devices is MQTT. MQTT is a lightweight publish and subscribe messaging transport protocol, and it's designed for machine-to-machine communication in low bandwidth environment. The word publish subscribe is the term to describe the communication model in MQTT. There are four important elements in MQTT, such as the below diagram. You can see the message flow are related to publisher, subscriber, topic, and broker. A publisher will publish data to the topic on the broker, and if there is a subscriber subscribe on the same topic, broker will help to publish the data to this subscriber. A publisher can publish data to more than one topic. Likewise, a subscriber can subscribe more than one topic. That's why MQTT is so popular, since users can subscribe every topic he would like to monitor and receive those data with broker's help. Simply put, all devices need a broker for processing the message. Those devices are not communicate to each other directly. Let's take a look at ADAM's role in MQTT. Here's the most common scenario for ADAM with MQTT. As below picture, ADAM acts as a publisher, so it can publish the I/O data to broker, and so if user want to receive those I/O data, user will be the subscriber to subscribe all the data topic from the broker. On the other hand, there's another scenario for user using ADAM with MQTT. If user wants to control ADAM's DO channel, user will become the publisher and have to send the valid control data in JSON format to the DO control topic. In this scenario, ADAM will become the subscriber, so ADAM can be controlled by the data sent from the broker. Here we will talk about different MQTT features by using different application examples. Let's see the first application scenario, the automatic car detection and garage door open system. First, the garage have to subscribe the car info topic, and user have to subscribe the door info topic. Then, when the car is arriving home, the car can publish the car arriving home to the MQTT broker. Later on, the broker will pass the car arriving info to the garage to opening the door. After the door is open, the broker will send door is open info to the user's cell phone. As you can see, this control concept is really simple, and MQTT can realize this application by its simple and lightweight feature. Here is another application scenario which can introduce the wheel topic and data return feature of MQTT. As you can see, in a solar plant, user can subscribe the charging status of solar panels. After 3 solar panels are charging complete, user will receive the charging complete message accordingly. If solar panel 3 is the last one finished charging, then the latest message stored on the broker will be solar panel 3 charging complete, which is the data return function in MQTT. Besides the data return function of MQTT, user can also subscribe the web topic of solar panel to monitor its status. For example, if solar panel 2 disconnects unexpectedly, user will receive solar panel 2 disconnect message from the broker. This is really helpful and useful for customers in a monitor and control system. Let's see the multi-subscribe and extensibility feature of MQTT by another application scenario. In a real application, there might have multiple devices in a controlled system. As the example here, you can see there are 3 ADAM remote I/O modules. If user wants to monitor all 3 ADAMs, he can subscribe the MQTT topic by using a wildcard character, the hashtag. Just as the example Advantech /hashtag illustrate here, then he can monitor those 3 ADAM at the same time. For the extensibility feature, since the wildcard character hashtag can map to the same level topics, it's convenient for product developers such as Advantech to develop new MQTT topic, which can be controlled under the same level. For example, if module subscribe Advantech MAC address and hashtag, when there is another MQTT topic newly defined, let's say Advantech MAC address restart, then user can just publish data to the newly defined topic to control ADAM accordingly. After understanding the MQTT feature by different application scenarios, let's move on to the MQTT standard. As mentioned here, MQTT was initially developed by IBM and Eurotech, but this protocol was adopted and published as an official standard by the OASIS, this organization. The MQTT standard ADAM support is the latest version, which is version 3.1.1. Here is the basic function introduction about MQTT Broker and Client. For Broker, emailing do the following 4 things. As highlighted here, they are accepting network connection and message published by client. Also have to process the subscribed unsubscribed requests from clients. Furthermore, broker also responsible for forwarding application messages that match client subscriptions. For client, he also do the following 4 mainly things. A MQTT client can publish message, subscribed message, unsubscribed message, also disconnect with the broker. Let's use this slide to summarize the MQTT features. First, it's a lightweight protocol for IoT messaging. Second, the communication model is published and subscribed as the picture shows. Third, it can realize one-to-many messaging. Fourth, the header of MQTT is really small, which is suitable for low network bandwidth application. 5. MQTT provides a quality of service data delivery. 6. The MQTT uses hierarchical topic structure and wildcard subscriptions, which is convenient for users to do management. Last, The last will message can let user know the client status. Here we will keep listing 5 important key terms in MQTT. The first one is client ID. It's easy to understand. Each client will have a unique ID when connecting to a MQTT broker. The second one is keep alive. This is a time interval that clients will send ping requests regularly to the broker to inform that this client is still alive. Then the broker will respond back with the ping response to each ping request. The third one is last will topic and last will message. This means broker will send last will message to all the clients who have subscribed the last will topic in case of client disconnection. So user can know each status of the client by using this feature. The fourth key term is return flag. This flag is for MQTT publish message. With this setting, the message can be stored on the broker. This feature can let user to know the last returned message on the topic. The last key term is clean session. This is for the client to decide whether it wants to establish a persistent session with broker or not in connect message. If clean session is false, broker will store all subscriptions for the client and also all missed message when subscribing with the QoS is 1 or 2. The clean session in ADAM module's default setting is true, and so far this option is not open for customer. To provide different quality of service on data delivery, MQTT has defined 3 levels of quality of service to ensure reliable messaging. For QoS 0, is also called the at most once. The broker and client will deliver the message once with no confirmation. It's the fire and forget. So it's suitable for sensor raw data transmit. And for QoS number 1, at least once. That means the broker or client will deliver the message at least once with confirmation required, but you might receive the duplicate message. And for QoS 2, exactly once. The broker or client will deliver the message exactly once by using a 4-step handshake. So it is suitable for highly important systems such as the cash flow or billing system. After the first chapter of MQTT Basic, we can move on to more detailed parts of MQTT packet. We will also use the real packet sent by ADAM module to let you better understand those important MQTT packets. The MQTT protocol works by exchanging MQTT packets. The MQTT packet is very simple, just as the picture below. It is composed by the following 3 parts. There are fixed header, the variable header, and payload. Let's take a look at the fixed header in MQTT packet. The fixed header is really important since it defines all the MQTT packet type in the header. As the picture below, there are total 16 bytes of MQTT message type. Here we will only introduce 3 important MQTT packets in this training module, which are connect, publish, and subscribe. The first one is the MQTT connect packet. This packet is sent when connecting to the broker, and in this packet, it can store all of the connection parameters such as the feature we just introduced previously in this slide. This slide clearly shows the information stored in connect packet. It's clear to see that the packet is a connect packet in the fixed header, And you can see other information such as the client ID stored in payload. And the client ID of ADAM is defined as ADAM model name and MAC address. When ADAM module wants to send the I/O data to broker, it will send a publish packet to the broker. The published packet will have the following parameters, just as the picture below. This slide clearly shows the information stored in published packet. As you can see here, the I/O data of ADAM is stored in payload. A client can send subscribe message to MQTT Broker for receiving relevant message. The subscribe topic name and the QoS setting can be seen in this packet. As you can see here, the subscribe topic of ADAM is Advantech MAC address and hashtag. Here is the short video clip for monitoring the MQTT packets in different published QoS level by using Wireshark. So first we set the published QoS to 0 and then start the Wireshark, and then we type MQTT for the filter. After we set the DO channel 0 to on, then we will see the published QoS level is equals 0 in Wireshark. Then we set the published QoS to level 1. And then we turn on the DO channel 1 to see how the changes in Wireshark. See, the published QoS become level 1 and with the publish egg. Next, we set the module's QoS to level 2. And still, we change the DO channel 1 status, and on Wireshark we will see the published QoS levels become QoS 2 with the 4-way handshake. With the basic knowledge and understand 3 important MQTT packets, we can start to use the MQTT function with ADAM. Firstly, we will introduce the MQTT setting in ADAM. Here we will talk about what's the requirement for using ADAM with MQTT, also the MQTT definition in ADAM. Then, we will introduce 2 broker types for user to experience the MQTT function of ADAM. Besides, we also provide a MQTT test page for user to check whether the MQTT function is working normally with ADAM. Finally, we will talk about the troubleshooting skills for using MQTT. Let's see the requirement for using ADAM with MQTT. As the table shown in here, if customer already have our module but it's in CE version, he still can have MQTT function by upgrading the firmware version without buying a new one. However, user need to use utility version after this version to configure MQTT setting of ADAM. The MQTT topic definition can be found in the startup menu on the support portal. As written here, the MQTT topic for I/O data is defined as Advantech/MAC address/data, which means ADAM will publish I/O data to this topic, and the data is in JSON format, just like the example here. For DIO module, the DIO control topic is defined as Advantech MAC address /control/ and DOX. The X means the channel number. If user wants to turn on DO channel 1, then he needs to publish the data in JSON format to this topic. The next one is where topic. If user wants to monitor the status of ADAM, he can subscribe this topic. Let's see the AI module MQTT topic definition here. For AI module, we provide the AI input range setting via MQTT. If user want to set the AI channel 1 to 0 to 20 mA, he needs to publish the example JSON data. Like the example here, the type 0 to 20 mA to the AI range configuration topic, which is the Advantech /MAC address /set /sensor /AI1. The steps to configure ADAM MQTT setting is really easy. After you upgrade to the utility version to version 2.05.11b02 and above, you will see the cloud page in the last menu. Here we provide 7 settings for user to configure the MQTT function of ADAM. The first one is enable MQTT setting. You must check this box to enable the MQTT function. Then you can define the broker IP at the host column. It can be IP address or URL, which is more friendly to user. For deadband, it's the minimum interval between publishing 2 MQTT messages for the module. For example, if there is 3 DIO changes within 1 second, then ADAM will only publish 1 DIO change message to the broker, which can prevent MQTT packet published excessively and cause network traffic. The return message setting is for user to decide whether to let broker store the last message of the topic. The last 2 settings are publish QoS and subscribe QoS, and there are the settings to define the message delivery quality between the broker and publisher, or broker and subscriber. Last but not least, don't forget to click the Apply button to make those settings effective. As introduced earlier, the MQTT application is achieved by the broker for processing the data sent from the client. In other words, you cannot use ADAM's MQTT function without a broker's help. Here we will introduce the most popular broker for you to test with ADAM. The Mosquitto MQTT Broker is an open source resource. It's free and you can download via below link. After you finish the installation, please check the environment path setting. It should be under this path written here. Later on, by opening a command line to run the mosquitto.exe file, you will see the broker is running successfully at port 1883 as below screenshot. After the broker running successfully, you can use the Mosquitto-sub as a client to subscribe data from Mosquitto Broker. Just open another command line and enter the below command to subscribe data. Then you will see the received MQTT data immediately. You can use the Mosquitto-pub as a client to publish data to MQTT Broker for controlling ADAM. Open another command line and enter the below command to publish data. Then you will see the logic status change on the DI channel 1 in utility. Another free broker can be used is provided by Eclipse. It's running on the cloud, so it's convenient for testing. When using this broker, please make sure that the module is in DHCP mode, and the IP setting must have the ability to connect to a public IP. Besides using the Mosquitto execution file to test whether user can receive the MQTT data or not, we also provide the ADAM MQTT test page in utility. User can experience the benefits of ADAM with MQTT in 4 steps. Please note that the path username, password, and TLS and the clean session function is not released. And this web page only supports the connection to broker over WebSocket. So if the broker doesn't support WebSocket, then this page won't be able to connect that broker and receive message. Step 1. Open the test page by the instruction here. Step 2. Enter the broker's IP in the host column. For example, here we set the iot.xlibs.org as the broker. Due to the default broker via WebSocket is port 80, we remain the default setting here and click Connect. Step 3. You can subscribe any topic you want with different QoS setting. You can also publish topic with correct data format to control ADAM via MQTT. Step 4. Enjoy the MQTT message displayed in the below column. Here is another video clip for using the MQTT test page to verify ADAM's MQTT function. And we launch this MQTT test page. As mentioned, we set the host port number to the default setting and click Connect. And then we make sure the module's broker setting is matched with the test page. And also we make sure the topic we subscribe on the test page is matched with the ADAM. And as you can see, we can see all the published message from ADAM. DO channel 1. So we receive another new message published from ADAM. And if we want to control ADAM, we publish the DO data to a certain DO channel, and we make sure the DO control topic is correct. The last part is the troubleshooting skill for the MQTT function with ADAM. If you cannot get the MQTT data from broker, please check the following 3 parts. First is for MQTT Broker. You have to use a broker for MQTT application. If broker is not running successfully, of course you cannot get the data from it. Second, for ADAM, please check the module setting with correct IP setting and MQTT function setting. Sometimes you might forget to enable the MQTT function. You can also use a Wireshark to cache the MQTT packet. This can always help you to find out where the communication problem is. Last one is for user. Please check whether you set the correct IP address of the broker, since you might connect to the wrong broker. For the subscribe topic, please make sure there is no any space or any typo on the topic. Otherwise, you won't be able to receive the correct data from broker. Here are the debug topology for catching the MQTT packet. And when using Wireshark to capture the MQTT packet, please follow different debug topology based on your application structure. And when broker run in PC, the topology is like here. And when broker run in cloud, the topology is like this picture. And please sure that the hub to capture the packet device is always between the MQTT client and broker for capturing the correct packet. Here is the first hands-on exercise. Please follow the steps here to finish the hands-on of subscribing ADAM's I/O data from Mosquitto. The first step is to set host name of your PC's IP, and here we use the ADAM 1651D version for the demo. And the next step is to run the Mosquitto broker in the command line. And then use Mosquitto-sub to subscribe the data from broker. If you enter the command correctly, you should see the I/O data published from ADAM in the command line. Here is the MQTT data subscribe result of this hands-on practice. And the whole process can be referred to this video. First, we open a command line to run the Mosquitto broker. So in Utility Cloud page, we enable the MQTT function and also enter the IP of this computer because the broker is running at this laptop. And then click apply to set the MQTT function of ADAM. As you can see, you already see lots of message receiving on the broker. Here is another video clip for subscribe ADAM's I/O data from Mosquitto MQTT Broker. We open a command line to run the Mosquitto-sub program. Enter the topic we want to subscribe. After we run it, we will see that the broker received the subscription from this program. And when the I/O channel of ADAM changed, this program will receive the I/O data because we already subscribed this topic. Here is the second handout in this training module, which is the publish DO control data to control ADAM. Please follow the steps here to finish this hands-on. And the first step is to set the hostname to your PC's IP because the broker is running on your PC. In the example here, we are also using the ADAM 1651D version. And then run the Mosquitto broker in command line on your PC. And then use the Mosquitto-pub to publish data from the broker. If you enter the command correctly, you should see the DL channel 0 of ADAM will become logic true after the Mosquitto-pub publish the data to the Mosquitto. and the result of the published DO control data to control ADAM is shown as below. And here is the video clip for the published DO control data to the Mosquitto MQTT Broker. First, we found the ADAM module and check the DO control topic and open a command line to run the Mosquitto/pod program, and to the topic we want to control, we send the control data to ADAM, and we will find the related channel become logic true, and if we enter false, then we will find the DO channel 0 become logic false. That's all for module 9. Thank you.